This Week in Virology, the podcast about viruses, the kind that make you sick. This Week in Virology, episode 58 for November 12th, 2009. Hi, everybody. It's Vincent Racaniello at the TWiV studio in New York City. Joining me today is Dick Despommier.
Hey, Vince.
How you doing, Dick?
Doing very well,
Haven't
Vince.
seen you in ages.
Oh, come on now. I was here 2 weeks ago.
I saw you this morning.
You did actually saw me this morning, too.
Gave a lecture to medical students. And also joining me in the TWiV, or joining us in the TWiV studio, is Dr. Joshua Stillman. You're here at Columbia, is that right?
I am. Yes, I'm an emergency doc here.
An emergency room physician.
Yeah, right.
Wow, the real deal. Excellent.
I
Good
see
to have
patients.
You're an impromptu addition today at TWiV, but we're welcome to have you. And just make sure we get everything right on the clinical side. And finally, lastly but not least, joining us via Skype is Alan Dove. Welcome, Alan.
Always a fun time to be here, even if I can't be seen.
It's a good thing for you, right?
Yes, perhaps especially if I can't be seen.
Well, we'll work on it so one day we can get you seen. Or perhaps you don't want to be seen.
I kind of like the narrator voice effect.
Uh-huh.
Well, journalists like to be heard and not seen, right?
That's right.
That's right.
Anyway, it's good to be back again. We missed a week together. It's always good to be here. I enjoy it a lot. We got a bunch of stories today.
We do.
So let's get right into it. Unless Dick has something to say. Nothing.
No, I'm all yours, Vince.
I should say that this morning, Dick, I gave a lecture in, microbiology and infectious diseases. What is it, a second-year course?
Yes.
Right.
And Josh also gave a lecture before me.
That's right.
I heard cysts when I walked in. I didn't know. Was it malaria?
It was an echinococcal cysts when you walked in.
Echinococcal. Well, we have to get him back for TWiP.
Sure.
Right.
So we have started a new podcast this week in parasitism.
Correct.
And
that's not social parasitism.
No, or people from Parasite.
So you started this other podcast on the back of TWiV.
That's right.
on the back. What does that mean on the back?
In the style of...
In the style of, yeah, Dick and I have recorded a couple of episodes, and they're going up, I think, tomorrow. The first one's going up tomorrow. So we'll have Josh on that for a full episode. You can tell us all about these echinococcal cysts.
He knows a lot about neurocysticercosis also.
I know nothing about that. I know about viruses, which is what this show is all about. And today our first story is an article on Nipah virus infection.
Yes.
I bet you've never seen a Nipah virus in the emergency room.
Not that I recognize. No.
So you, what a great way to say it. You you work here at Columbia in the ER, right?
I do.
And
168th Street in Broadway.
Have you worked in other ERs in other cities?
I also run an emergency room up in Westchester.
Ah, okay.
Where I think I've seen several Nipah viruses.
So have you seen a lot of H1N1 this year, I presume?
Yeah, it's going around now.
Maybe get your thoughts on that before you leave. This article, though, is in PLOS Pathogens.
Uh-huh.
This is from October, I believe. So PLOS is Public Library of Science, the open access journal. And this is about an interesting treatment, I thought, because, these Nipah and Hendra are these two extremely lethal viruses that appear to spread from fruit bats to people.
Correct.
Well, horses, too. Of course, the Hendra is infecting the veterinarians in Australia.
Exactly.
It's affecting the horses, the racehorse industry. Nipah, also CNS disease, respiratory disease. These are very dangerous viruses, so you can't just work with them in the laboratory.
Right.
Very difficult to make a vaccine. And even to have an animal model is very hard. But in this article, what they have done is they've shown that ferrets can be infected with Nipah. So ferrets, as you know, are a great model for influenza.
So this appears to be a rather promiscuous virus.
It is. And in what sense did you mean that? Hosts or tissues within the host?
Both, but I know that it infects bats, and I know it infects pigs.
Right.
And I know it infects people, and now I know it infects ferrets.
Yes, in the laboratory anyway.
So that's pretty promiscuous, wouldn't you say?
Yes, and in fact, within the ferret, it infects many different tissues.
So
it has a broad tropism, and it's exactly what they say in this article.
It's amazing.
Yeah. Well, do you think that's not a property of most viruses?
Well,
if you said yes, you would be right.
I'll say yes. No, I was just thinking of a virus that's specific for its hosts. I mean, there are many viruses that we can't catch because we're just not suitable
right.
we don't have the right receptors
Or something else.
or something else.
No, there are very few viruses that infect many, many tissues, in fact.
Right.
Most are specific.
Yeah.
So this is kind of unusual. It's unfortunate because the more tissues you infect, you have more problems, right?
Sure. I mean, I was thinking of the AIDS virus, for instance, the
Mhm.
HIV virus. It's specific just to people, but you can give it to chimpanzees also because they have the right receptor. Is that correct?
Well, they can get SIV,
Right.
right, the simian version.
But beyond that,
yeah, it's
couldn't
quite
give it-
limited.
couldn't get it to ferrets or rats or pigs or
Right. No,
bats.
you have to do special things to get it to infect other monkeys and
Exactly.
primates.
So that takes us back to our
And
original.
even within people, the specificity is narrow. White blood cells, CD4 positive cells for the
See
most
that?
part, right?
See that?
Maybe a few other cell types. But
So we continue to reference back to these basic virology sessions that we've had on This Week in Virology as well, and this points up that.
absolutely. We should always do that if we can. I'm
Right.
going to depend on you to remind me.
Since I don't know much else, I have nothing else to do but think about that.
So this article I found interesting because this virus has to be worked with in BSL-4 containment, which is the highest containment. You have to have a special laboratory with air pressure going a certain way, and you have to gown up, and it's very, very difficult to do any sort of work.
Well, and
with
it's the
this.
whole spacesuit.
Spacesuit,
setup. Well, it's not
exactly.
just gowning
Dustin
up.
Hoffman
Spacesuit,
lookalike.
sorry, not gowns. I don't want to. It's not just gowns and face masks.
Right.
No, it's a spacesuit. And,
Right.
How many BSL-4 facilities are there in this country?
Oh, well, that's a good. Do you know the answer, Alan?
There are 2 or 3, I think, and they're in the process of trying to build more. But in fact, one of them they're trying to get approved to either build or expand in Boston, and it's creating an enormous amount of controversy because, of course,
I'll bet.
nobody wants to be next door to one of those.
No, they don't.
But I think there's one in Galveston.
Yes.
I think so.
and there's one in Hamilton
There's one in Atlanta,
In
and
Atlanta.
there's one in Frederick, Maryland.
and
So
in
the-
Hamilton, Montana, I bet, too.
Yeah. There's not one in New York. There are some BSL-3s here.
Right there. What
Yeah.
about Plum Island?
I think that's closed. I don't think it's operative
Oh, is
anymore.
that true?
As far as I
I'm
know.
not sure Plum Island had a BSL-4, did they?
I didn't. I went and I didn't have to put a
Don't know.
spacesuit
I
on.
don't know.
They were an agricultural containment facility. The logic being that the cows
Yeah.
would not swim across the channel.
They had foot and mouth disease virus
Right.
there, but in fact, deer used to swim across the channel.
Right.
Plum gut, it was called.
Yep.
But
I've
I went.
sailed Plum gut.
You've sailed. It's very rough, right?
It can be.
So they've seen deer swimming from the mainland to
Good heavens.
Plum Island. They don't right. You don't have to put a spacesuit on. You do. You go in and you have to change, and you go through a spray. You
Have
know,
to get disinfected.
yeah, either both ways.
Right.
Plum Island's a very interesting place. Someday I'll tell Plum Island stories.
Okay.
Yeah, there are very few of these BSL-4. So this one was done. Well, it's done in Australia, Frederick, and I
in
presume
Frederick,
has a BSL-4, right?
Yep.
So how do you get a virus from its native habitat to a BSL-4 facility that's this dangerous?
in a multiply wrapped package. They actually no. They have. I think this is standard procedure. There are usually a set of layers of packaging,
Right.
and what they'll do is they'll have the virus in an Eppendorf or whatever, but then that'll be inside a canister that has
Okay.
some bleach in it.
Oh, got it.
Yeah,
So-
many layers, right?
Yeah, and then layered and layered and layered. And,
But also
Yep.
the plane that it's in, everyone knows that this is there.
right.
And,
And the guy who's delivering it is handcuffed to the package that has.
it's not picked up by a FedEx driver at the
Right.
airport. You usually go get it.
And Samuel L. Jackson is. Oh no, that was something else. That was
It's a good question, though.
Right.
It's not easy to do. As you know, Ian Lipkin here gets high, what's the word? Very dangerous specimens from
Yes.
all of. They're potentially containing BSL-4 agents, but he has a BSL-3 laboratory here.
Right.
He has an elevator made that just goes right up to that floor, and they put it right in there. But then they add chemicals that disrupt infectivity because they just want to sequence whatever's in the sample. They don't
Right.
need to grow the virus.
That's right. They amplify it.
So they can do that because they're not working with it. But in this case, they're working with virus and they're putting it into ferrets. They drip it in their nose, and they get a disease that looks like the disease in people.
Sure.
It's a disseminated infection. They get respiratory and neurological symptoms, and they look. This is the way you characterize a new animal model. You measure virus production in different tissues at different times after infection. You look at the pathology. You take out various organs, and you just see how it compares to the human disease. So they have lots of that in this paper. But the key here is that they have previously made a monoclonal antibody against one of the viral glycoproteins, the viral glycoprotein of Nipah, and that's a neutralizing antibody. It blocks infection. What they show here is that if you infect ferrets and then 10 hours later give them this antibody, and you can give it to them intravenously or intraperitoneally, it will protect them from lethal disease.
Oh.
So that's interesting. So that is a sort of a promising therapy for someone who's known to be infected. There's nothing you could do at the moment, so perhaps you could give them this monoclonal antibody.
Now, it's interesting. This is a human monoclonal,
Yes.
but apparently they injected it directly into the ferrets, and I guess it survived long enough in the bloodstream and wasn't recognized as foreign quickly enough to be just neutralized.
Right.
Yeah, I mean, it's a 10-hour window they had, right?
Right.
So that's apparently, but in people, you're right. That's a good point. This is a human monoclonal, which means you could put this in people.
Right.
And it would presumably last longer.
Why do you think they developed that? I know.
Why? Why do you think?
Because these people want to work with this virus, and if they ever catch it, they can now interfere with it.
That's a good point, yeah.
They have some level of protection, which is the way Jordi Casals got saved from the original outbreak of Lhasa, as you will recall from episode, 2?
So the point is that even in BSL-4, mistakes will happen,
Oh.
and you will get contaminated. So
You
that's a
can
good
count on
point.
it. You can count
So
on
you
it.
think that this is more for that than for people. But if this were put through clinical trials, which is, I suppose, what you would have to do to be able to use it therapeutically, and then if someone was contaminated in Australia or India, where Nipah is, they could get this therapy.
Or Malaysia. Wherever
Actually, the clinical trials are an interesting problem because you thankfully don't have very many infections of this.
That's a good point. I guess you would
don't.
just look for
But they're outbreaks.
You'd look for safety and toxicity,
Sure.
and then you'd probably have to get what's called an emergency use authorization, which is where the FDA
That's
says,
right,
okay,
that's right.
we're not really approving the efficacy of this, but
Correct.
if it's an emergency, you can go ahead and use it.
Right, so even doing a dose-finding study would be difficult.
Right.
Safety and efficacy might be as far as you
Yeah.
get.
Because there aren't enough infections. I mean, they have actually summarized it here. There have been 13 Hendra outbreaks, and they're relatively small, and 9 Nipah outbreaks, primarily in Bangladesh and India.
Right.
And of course, you can't do it the way the old-time virologists like Walter Reed would have done it.
He would have fed himself or inhaled Nipah.
Would have just given himself the virus like he did with yellow fever.
I didn't actually do that, Alan.
No?
No,
Didn't?
the rumor has it that he did it, but he actually didn't do it.
Oh, I thought he was...
He oversaw the project, but he wasn't actually present during that time. Down in
okay.
down in Cuba, where they did it.
Ah, the old choose a volunteer approach.
So Finley. Well, it was Finley who was overseeing the whole thing.
Okay.
So that's that, basically. It's an interesting application. I think that the human monoclonal is an interesting point. And also this monoclonal is blocking infection. They knew that already from cell culture. And now in animals it works. So it might work in people, but we can't assume that it would.
No.
Right.
If the safety looked good, the first person who gets infected accidentally
I'd take
would
it.
be the test. You would
Or
take it.
in an outbreak, I mean, I'm there in a minute.
Yeah.
Sure.
Yeah. I mean, if this is safe.
I have nothing else to do.
Well, with Jordi Casals, they gave him someone's serum who
That's
had
true.
recovered, right?
That is true.
And we didn't know if she had other infections,
We
right?
did not.
But it's to save his life, right?
It did save his life.
So
What were the odds that she had a worse infection?
yeah,
Right.
she was working in Nigeria. I think they were pretty good, right?
Oh,
Okay.
absolutely.
But although you're right, she would have shown symptoms of it. So
She did. That's why she was flown back
I mean,
to
this
Colombia.
is the 60s. Maybe she had HIV and we didn't know it at the time, right?
Yeah,
So he
well.
could have developed it 10 years later.
Could have.
But those are the chances you take. You have to balance, right?
Yep.
Sure.
I guess you
Without it, he would have died.
You would have, yeah.
We think he would have died.
Do you know Jordi?
I know of the
you're
story
Too,
only,
you're too
yeah.
young to
Yeah.
know him, but he was treated here by Harold New, who used to be the head of ID.
I came here for Harold and for Dick.
Yeah.
Yeah.
Legendary Harold New, yeah.
That's right.
Okay, that's the first story for today. And the second one is it's also interesting, a Lancet article questioning whether it's a good idea to immunize children versus influenza every year. And the idea is that normally, if you're not immunized, you would have natural infection with influenza, and you would build up cross-protective immunity. So you would be immune or not immune, protected against serious disease with other serotypes.
Right.
So you have a long history or an influenza experience, as we call it, and then you would have less serious disease. And that may be why older people this year have less serious H1N1 disease. Now, the evidence for this is that in animals, it's been shown in ferrets and mice that if you inoculate them with, say, an H1N1, a seasonal H1N1 or a seasonal H3N2, and then you challenge with the pandemic H1N1, the animals make less virus and have less severe disease. So you don't protect, but you ameliorate the disease. And the idea is that maybe there are T-cell epitopes involved, conserved T-cell epitopes that give you some protection. So this Lancet article said, are we doing the wrong thing by immunizing children every year and preventing them from being protected in the case of a pandemic?
I actually, I have a couple of problems with this.
So go ahead, Alan.
Yeah, the first thing that occurred to me was why exactly did the Lancet need to publish this article right this very instant?
Timing is bad, right?
Could they possibly have waited 3 months? Would that really have derailed the discussion on this? But then the scientific problems I have with it are first of all, you're making human suggestions about human public policy based on a mouse experiment,
right?
And secondly, they kind of disregard the notion that when they're talking about getting protective immunity and cross-reactive immunity. That's only true for those who survived.
That's right.
Whereas I believe the survival rate for the vaccine is still 100%, right?
The survival rate meaning
meaning the people who get the vaccine and live through it. Whereas if you get the vaccine, if you get the virus, you've got some non-zero chance of.
That's true.
No, that's true. I mean, you can.
Virus is a lot more dangerous than the vaccine.
There is a lethality rate, yeah. Well, the problem here is that this is only going to help you in the pandemic year, which is once every 20 to 30 years, right?
That too.
So you want kids not to get sick every year in hopes that in 20 years they'll be okay, because the next one isn't coming around for 20 or 30 years. So I agree that it's probably not a good timing, but on the other hand, you don't want to censor science, right?
Oh, no, certainly not.
Do you have any thoughts as to why they did it right now? I mean, do you have a thought on that?
I do have a thought.
Oh, I have a thought on that too.
Go ahead, Alan.
Well, it's hot news.
Yeah, that's it.
They wanted sensation.
I think
journals are in the business of publishing the science and forwarding the science, but they are also very much in the business of drawing the eyeballs.
Yeah. Unfortunately, anything flu-related now gets a lot of press, and this got a lot. And in fact, there was a related story out of Canada, right? This is sort of related to that, which we haven't seen yet. Is that correct, Alan?
We still have not seen those data.
Yeah, I think they're related.
Nor will
to this.
you.
Maybe they were rejected. We discussed this a few weeks ago, but I think it's the same issue that you have this possible cross-reactive. There was a very strong editorial in Lancet, in which they said basically you never make immunization policy based on an animal model, which is a strong statement, if anything. And then they said basically, it's kids get sick and it's preventable. It makes no sense to let them get sick on a theoretical possibility.
Especially when you have a good vaccine.
I don't think this group, which is from the Netherlands, is saying we should stop, but they're saying we should research this more. And that's really, in the end, unfortunately, it's at the last paragraph, and it kind of gets lost in all the publicity. So there is a scientific basis for what they're saying in animals, and it's worth investigating. So you can look at the data on what happens in people. In fact, there was a small study done after the 1957 pandemic, which suggested that people who had flu before the pandemic had a lower rate of infection during the pandemic than people who had fewer infections. So you need a lot of data to go through and conclude something like that. But it's the kind of thing maybe now we could do after this pandemic is over.
And having lit into these people right away, I should point out, this is actually a very important discussion to have.
Yeah.
That it's a very relevant academic debate to carry on, and I certainly don't think the journal should have killed it. I just think for the sake of public health, they probably could have waited a few months.
Yeah.
Is anybody looking at using this as an opportunity to do such a study? looking at people who were vaccinated versus those who were not and who got the flu and the quality of immune response that they have?
I'm not aware. It's that's an epidemiological study, and I hope someone is. I know laboratory studies are ongoing to try and understand if there is. This is called heterosubtypic immunity, and trying to understand the basis for that, and if we could make vaccines that would give you cross-protective immunity. But the epi, are you aware of any epi, Alan?
Not that I've heard about. I certainly hope among all the data that we're collecting that somebody is at least collecting the data, even if they don't have the specific outline done yet.
I mean, this year so much data is being collected that I guess it can be looked at some point. Mm-hmm. So hopefully it's being done. I don't know the answer to that.
Yeah, you may even be able to do population level analyses because the distribution of the vaccine has been slightly uneven.
Exactly.
Okay, the next story is from Alan Dove. More debate about N95 masks versus surgical masks for flu protection. So why don't you tell us about this? I'd be interested in your thoughts, Jason.
Josh,
sorry.
That's okay.
Josh, on this as well. So what's this about, Alan?
Well, so there's this open letter from the Society for Healthcare Epidemiology, the Infectious Diseases Society of America, and Association of Professionals in Infection Control. These are organizations that are infectious disease physicians and such. And they have essentially issued this open letter to the CDC and to OSHA saying that you should not be enforcing this current guidance about N95 respirators. And just to recap, what OSHA and the CDC are saying is that medical personnel should wear these N95 rated respirators when they're dealing with flu patients, because this is the type of mask that is perhaps sufficient to limit spread. And the OSHA and CDC also say that it's not worthwhile to use standard surgical masks because these have not been shown to be a benefit. There was just some research that came out on this that suggests that the surgical masks may actually be, if not as good, maybe almost as good as N95 respirators.
For spread from a physician
patients,
to patient.
Right, from physician to patient, I think was the study, but the thinking is that it might also be patient to physician. So the idea here is, well, we shouldn't be telling people not to use these surgical masks because, first of all, they're going to run short of N95 respirators, which already, anytime there's something like this, everybody makes a run on Home Depot and buys out the available stock of N95 respirators, even if they don't know why or how to use them. But then on top of that, so the hospitals are probably going to have a shortage. These respirators are not they're not terribly expensive, but they're not as cheap as these disposable surgical masks. So why not encourage people to use the surgical masks if the respirators aren't available? In other words, you should be encouraging both. And so they're expressing their concern over this policy. I don't know if it's going to get them anywhere. I don't know if there's so much confusion on this issue already that probably a lot of people in hospital settings aren't bothering anyway. Josh, is that?
I'm not seeing much use of N95 respirators in the emergency department in the city here.
Okay. Interesting. So this is not an issue.
I think it's because we're not so worried about it. If this were SARS, I think we would all be using it without any question. So the clinical impression that I have is that for acquisition of infection from patients by physicians, that the two masks are not comparable, that surgical mask is grossly less effective than is the N95 respirator. And so for our own self-protection, I think that's the way we would go if we were worried about the virus. Most of us are getting H1N1 vaccinated and get the seasonal flu vaccine. So I think there's generally less worry about actually acquiring it. And then for transmission, it makes sense to me that actually both would be comparably effective.
Right.
I think the studies have been equivocal, right? Some studies say a face mask is as good and others say an N95 is better. and the CDC has decided that to play it safe, I think. But so here in New York, you're not required to wear an N95. Right?
Well, we isolate all influenza-like illnesses in the emergency department up front. That is a decision made by a triage nurse at triage, and then the physicians approach the patients that way. Now, I'm seeing a lot of influenza-like illnesses slip through the cracks, but not very febrile ones. So patients with fevers over 102 or so pretty much get isolated, and we look at them as potentially sicker than those who come in with a temperature of 100.5. I'm not sure there's any basis for that, but and then we're approaching them. I think there's less fear about this particular virus than there has been about other epidemics.
So, because we have vaccines.
Yeah.
So you don't
and treatments.
Put an N95 on when you approach a patient with ILI.
Right. If they're looking ill and they're in isolation, then I do.
You do. I see. Okay. So what do you do then? How would you work up a suspected influenza case?
It's become a problem because we do rapid influenza testing, and it is seeming to be unreliable for this virus.
It's about 50% false negatives, right? That's what the CDC has said. So that's what you have rapid tests in the ER, right?
We have rapid tests available 24/7, I think, now.
So if you have a positive on the rapid test, you start antivirals?
Right, that would be straightforward.
Yeah.
The problem is with the negatives, and we continue to keep them under isolation for, I think, the final results 48 hours out.
Now, you start antivirals without knowing necessarily whether it's H1N1 or a different strain.
That's correct.
Okay.
Nowadays, it's over 95% H1N1.
Yeah, and patients who come in with infiltrates and are looking critically ill, who we would normally just treat with antibiotics, we're also starting antivirals. Tamiflu up front empirically, and would stop it then if I guess it's a PCR is the final test.
So you wait for a PCR.
Yeah.
Which we have the capability to do here, right?
Yeah. I'm not positive if it's PCR or ELISA. Do you know?
It's either PCR or viral culture.
Yeah, then it's a PCR.
There are there are a couple of tests that have just gotten emergency use authorizations from the FDA that are PCR based and definitive in serotyping.
Yeah, the PCR is much better than the rapid. We clearly need a more reliable rapid test.
Yeah,
and this pandemic has really pointed that out. It's very interesting. Okay, well, this sounds to me like it's almost a non-issue. Although I was on a podcast about 2 months ago it was an emergency medical tech podcast. These guys who drive the trucks, they have their own podcasts, and they invited me on one of them. And
cool.
One of the guys was saying, we don't have enough N95s to change it every time we go out. And he wasn't sure what he was going to do. So this is the same issue, Well, if you don't have enough, you use a surgical mask, right? And you hope for the best, I suppose. Nothing else you can do.
Yeah, and as I say, I think the confusion on this at this point has gotten so thorough that it doesn't matter what the public policy is.
Yeah. And unfortunately, the public, if they get wind of this, they get even more confused.
Right.
Telling them vaccinating kids might not be a good idea.
Yeah,
sure.
Which face mask to wear.
Yeah.
Well, the CDC says in public you shouldn't bother with face masks, right?
Right.
It's not going to help you very much, but because they're not properly deployed most of the time. Josh, do you need to go now, or do you want to stay?
I do. What's the next topic? Is weather patterns.
Weather patterns and dengue.
I'm finding it fascinating.
Come back.
I'll stick for this last one, and then I'll go.
All right. Yeah. So we'll do weather. This one I picked for you, Dick. Weather patterns help predict dengue outbreaks.
Well, sure.
And I don't quite understand it, so I'm hoping you will help. And basically, they did a study in China.
Yes.
Relating incidents of dengue.
Yes.
Which is a flavivirus.
It is.
And it's mosquito-borne?
It is.
What mosquito?
Aedes aegypti can carry it, but lots of others too. But tree-hole mosquitoes primarily, Aedes species. In this case, it might even be the Asian tiger mosquito.
And this is a serious disease, potentially serious?
Well, it's called breakbone fever. So if you catch it, it feels like your bones are going to break.
Yeah, it hurts. 2.5 billion people at risk.
That's right.
Hey, Josh, you ever seen dengue?
Oh, yeah. Yeah, we get it.
Did you ever catch it? He's gone to the tropics a lot.
No, I've never caught it. I think you have to be exposed to multiple serotypes, right? In order to catch it.
The first infection is the mild or possibly... there
are
then when you get reinfected with a different serotype, then you can have the more serious hemorrhagic fever, So you have seen it here in New York City?
Yeah.
Wow.
It's the transmission is through the Caribbean. We have a very heavy Dominican population here, and so it's transmitted down there.
So it's imported, basically.
Yeah.
Is there any
And
endogenous?
There is. Texas.
Ah, really?
Oh, yeah.
Aedes aegypti?
Asian tiger mosquito.
Ah, okay. Josh,
And Aedes aegypti.
what were you going to say, Josh?
No, I was going to say that actually what we see during the outbreaks in the Caribbean is we see an increase in the number here, and it's simply because our patients travel there and they come back with the illness. And if you get a good history, you find out that they've been to the countryside, they've been bitten by mosquitoes, they were in a town where a lot of people had dengue. Mm-hmm. If you ask it all, you can find out actually. That was
Harold Newstick. He was the king of that. He said, get a good history and you'll find out what's going on.
Exactly.
He was really a pioneer in that. You knew Harold,
I knew
right?
him very, very well.
He could always figure out when there were outbreaks. He would start asking where they've been and he could figure it all out. It's too bad he didn't write a book about this. It's really lost. Anyway, Dick, in this study in China, they said high temperatures, humidity, and low wind speed are associated with high occurrence of dengue fever. Is that not unexpected?
Not unexpected.
Now, high temperatures, why?
Well, the mosquitoes breed faster. Mm-hmm. The virus replicates to a higher level inside each mosquito.
Okay.
And that gives them more bang for their buck.
Humidity? Why would that
Humidity actually favors the survival of the mosquitoes, so they don't dry out, basically.
And low wind speed.
Well, that's right. That means they don't blow away from your environment.
So if it's too windy, they can't bite you? Or they can't even smell you? Or how does that work?
That's probably right, by the way. They probably can't even smell you. They can't follow the trail of CO2 to you, which is what they're following.
Well, and they're also not terribly great flyers.
That's true, too.
So they blow away.
These are all peridomestic species. That means that they're breeding right next to where you live. Mm-hmm. So this is an infection in high-density population areas.
Right.
And it's a tree-hole breeding mosquito. By that I mean the entire genus of Aedes breeds in temporary bodies of water. And I think we've talked about this before on a previous issue. When we talked about dengue, as a matter of fact, we had one on dengue.
Yeah.
But I'll just summarize it. The mosquito, the female mosquito, when it rains, she lays her eggs at the top of the water mark for whatever vessel the water is in, hoping that the water doesn't go up any higher. The eggs then dry out and actually are almost lyophilized. The water level then retreats inside and it accumulates a soup, a nutrient broth, basically, which is essential for the survival of these mosquitoes. And then before this actually dries out, it rains again, and perhaps the rain takes the water level above the egg mark, the egg line in the container. The eggs hatch. Now it's a soup that's fully laden with food, and the mosquitoes are filter feeders. And in a week from that point on, they are ready to develop into adults. So temporary bodies of water, old tin cans, turned over bird baths, canoes, tires.
The gutters and downspouts on your house, if they're clogged?
If they're clogged. Mm-hmm. If they're clogged. And tree holes, that insects make, and birds and squirrels and that sort of thing. So it's a very unusual brand of mosquito, basically. Culex and Anopheline mosquitoes require permanent bodies of water.
So this is an example of medical ecology.
It certainly is.
The course that you founded here, correct?
Yeah.
Because can we use this in any way to help prevent infection?
Well, if you can predict when these water levels will rise again above the certain ones, then you can, of course.
I guess we can't control the weather, so...
We cannot. Well, we can, but only adversely. We can just keep adding to the greenhouse gases and control it, sure.
Very good. All right.
But an interesting part about this is in China, about 15 years ago, Bangladesh had no dengue whatsoever. None. And along came a cyclone and picked up the mosquitoes from India and swept them and plopped them right down into Bangladesh. And from that point on, even in downtown Dakar, there were outbreaks of dengue. Yeah. So a single weather event can alter the course of history.
Makes sense. It can blow them into the area. Sure.
Exactly right.
All right. There's your dengue article. Thanks for joining us.
Okay, Josh.
Great to see you. Wonderful to see this happening.
Come back another time.
Yeah, we can be the doctor on
That
call.
would be fabulous. Yeah,
We've got Dr. Josh Stillman.
I'd be delighted to participate.
Great, thanks. I'll get your email and we'll be talking.
Great.
Thanks a lot. Okay, while Josh is making his way out, let's have a word from the sponsors of this episode of TWiV, Citrix, the makers of GoToMyPC. Here's the problem. A typical work week used to be Monday through Friday, 9 to 5.
Yeah, I know. I
But
get
times
tired of
have
that.
changed.
Really?
Times have changed. Most of us are spending more and more hours stuck at the office.
Huh.
You're missing out on important family events, putting off your personal life. That's why I recommend GoToMyPC to access your office computer from home. So you don't have to be at the office to get your work done. You can work from home early in the morning, avoid the traffic, leave later, leave earlier, leave later, during the weekend, after you've done the things you want or need to do.
Exactly.
Here's what our listeners can do. Try GoToMyPC free for 30 days. That's a month of unlimited remote access for free. And for this special offer, you must visit www.gotomypc.com/podcast. That's gotomypc.com/podcast for a free trial. And we thank Citrix for their support of TWiV. Alan, you could go to ustream.tv/channel/TWiV. And you can see us if you'd like.
I did that briefly at the beginning, and the audio was coming through, and I thought it might echo.
Yes.
Wow.
So did you see an image, though?
I did. I saw you guys sitting in the office.
Oh, dear.
Excellent. Glad
I'm sorry,
to see
the TWiV studio.
This is the TWiV studio.
That's,
Yes.
that's
I
right.
thought that was cool, Josh, coming in here because he's
yeah.
an ER. I always wanted to have an ER physician tell
Well,
us what you do.
He'll be happy to come back.
Yeah,
He's a good friend. He's a good friend.
Very
and
good.
He's in his 13th year of helping us teach our parasitic disease course to our medical students.
So he has training in parasitic
He
diseases.
loves the subject. So
Yes.
we're going to have him on the TWiP.
TWiP to talk about echinococcus. What was the name of this?
Yeah, no, you got it. That's
Good.
right.
Okay, this brings us to our last story. Antarctica's icy lakes are home to a surprisingly diverse community of viruses, including some that were previously unidentified.
How unusual.
And this was sent to us by Russ. Thank you, Russ.
Wait a minute. Antarctica
You know where
has
that is, Dick?
lakes?
Yeah.
They have lakes?
You didn't know that,
I'm
Dick?
playing the foil here, of course.
Doctor Ecology.
No, I knew they had lakes, but the audience might be saying, wait a minute.
Explain that. I mean,
How could there be lakes on the frozen...
Well, isn't it under the ice?
But of course it is.
Yes.
So why is it a lake? Because it's a freshwater body or something?
Yes, and it's liquid.
Right. It's not salty, though.
The biggest one down there is called Lake Vostok.
Is that the one that's involved here?
No, they haven't drilled into that one yet.
Okay.
The Russians are doing that job.
Let's
These
see.
lakes have been underneath ice for millions of years.
This is Lake Limnopolar. Or is that the right way to say it?
I guess.
Do you know this area, Dick? I thought you might.
Oh, well, I know of the science that
Yeah.
that attempts now to see if they can look back in time,
Mhm.
because these might be time capsules for life before Antarctica froze over.
Maybe. But they have to drill through the ice.
They do.
They get some water, and they filter it and concentrate it, and they have viruses there. They
Right.
do two things. They actually look at them by electron microscopy.
Oh, yes.
You see the photos here,
I
Dick?
do. I do.
These are they're bacteriophages, but there are also eukaryotic viruses that
Wow.
they see. Beautiful. Beautiful
Amazing
pictures.
stuff, huh?
I don't know if you're looking at this, Alan, but there's some very unusual viruses here.
Yeah.
There's this little pod-shaped virus.
Looks like a lemon.
Well, it looks like a lemon, yes. And then they also sequence the total DNA. So they're looking
Wow.
specifically for DNA viruses because they just amplify the DNA with random DNA primers. So there's no reverse transcription step.
Are these bacteriophages of archaebacteria?
Well, that's a good question.
Because hardly anything else lives down.
They're dominated by bacteriophage sequences, but also a large proportion of sequences related to eukaryotic viruses, not previously identified in aquatic environments.
Wow. So maybe there are lots of protozoans down there.
That's a good question. They talk about the biome in this area. So they have bacteria, algae,
Right.
rotifers, and protozoa,
See that?
and a macrozooplankton community,
Ha!
including copepods and fairy shrimps,
Look at that.
Bronchinecta gaini,
That's pretty high up on the evolutionary
aquatic
tree of
moss.
things.
And I don't see any archaea. Alan, do you know anything about archaea in Antarctica?
I don't. It seems like you would expect to find them there, but other than that,
Psychrophiles.
Yeah, it's extreme, right?
yeah.
The other cool thing here is that they did it in the spring and in the summer.
Yes.
So they say we observe the transition from an ice-covered lake in spring to an open-water lake in the summer led to a change from a single-stranded to a double-stranded DNA virus-dominated assemblage.
Uh-huh.
So in the summer, the lake is
Okay.
open. There's no ice, and that maybe they have different kinds of organisms there, so they have a different virus population.
Sure. That's quite different from Lake Vostok. Lake Vostok is as big as Lake Erie.
Mhm.
And it's under ice. It's under a mile of ice.
Oh my gosh! Can they?
So it's
drill
under
through?
ice even in the summer.
It's
Yeah.
permanently under ice. It's been like that for millions of years, and so they haven't yet broken through
Uh-huh.
to go into the lake because they're afraid of contamination.
I see.
So they're
Well,
trying to
it's a
figure
long
out.
way to drill.
No, they can do it, Alan. That's not the problem.
Okay.
They're 90% down there, but they're afraid to go the rest of the way without working out a foolproof way of not contaminating the lake
Right.
to make sure that what they do find was there and not something they put there.
Yeah.
And also to make sure that they don't destroy it.
Yeah, exactly. If there is something there.
Interesting.
So they don't know, but this is a prelude to go out to Europa.
Oh, this will be totally different, I'm sure, right?
Yeah, but they'll use the same drilling methods, I think, to
And
melt their way down through the ice.
That's a mile is.
A mile is huge. It's a mile of ice. Can you imagine how much ice there is in Antarctica? Amazing
But
amounts.
Dick,
Well,
it's
less
all,
and less.
Yeah, it's going to be all gone eventually, right?
You know, well, we tend to think in those directions, but if you know the percentage of ice that's actually gone versus the amount that's there, it's a trivial amount.
Sure.
It's a huge amount
Yeah.
of ice. And same with Greenland.
Take a long time. Well, the interesting thing here is that they say that they had thought that maybe these cold environments would have low biological diversity,
Yeah,
but it's
well-
not true.
Why is there a lake underneath a mile's worth of ice?
I don't know. I have no idea.
How does it stay liquid?
You tell me.
Geothermal
Geothermal heat?
Yeah, there are volcanoes underneath them. In fact, there's one active volcano on the surface, Ibris. I believe the name of it is Ibris.
What's on the bottom of these lakes? Dirt?
We don't know.
It's not ice, is
We
it?
don't know.
So that one possibility is that they're encapsulated in ice.
Right. But I think they're kept liquid by the geothermal vents at the bottom.
I see.
So I think you'd find ooze at the bottom.
Fascinating stuff.
Yes.
So then how close is the sea? And why doesn't it mix with it?
It's
Because the ice is
huge.
it's far
huge
away.
amounts of
ice.
areas under. It's like hundreds of miles inland.
Okay.
It's the volcano, by the way, is Erebus,
Erebus.
Nice.
I was close.
who was the son of Chaos
Ah, of course.
mythology.
Well,
Yeah.
the cool thing here is that these sequences are now in the database, so you could go and take them and make these new viruses and study them. Although they don't grow in HeLa cells, you have to have different hosts for this. but,
Copepod cells.
fascinating that we still continue to find the diversity in the viruses. Even though we've sequenced the ocean, there's still more. What about the North Pole? Anything interesting up there?
There's no ice cap there.
It's all water?
It's all sea ice.
No lakes, right?
No.
But I bet there are viruses in that.
Oh,
right?
of course there are.
I don't know if that's been looked at. These are expensive studies, of course. Okay. And
Craig Venter probably knows the answer.
and
to
he
that.
knows all these answers.
Yeah, but you can't sail over the ice, so he's not.
Wait a while, there won't be any ice.
That's right.
Let's tackle a few email here
Good deal.
before we wrap it up.
Yep.
William writes, Gentlemen, as I hike the beautiful Sierras, I listen to my podcast of TWiV every week and love your format.
All right.
I got interested in viruses when I did HIV work for several years. I'm a hard-working physician who has signed the front side of paychecks for years. I cringe when the occasional Bush hatred, so typical of the liberal university community, slips into your casual give and take. My physician friends whom I have turned on to TWiV noted the same thing. Let's keep politics out of your classroom. Please remember that all of us are not tenured professors and worry weekly about meeting payroll under Obama health reform in the same way you may have wondered about securing the next grant. I am anxiously awaiting your parasitology TWiVs. I would like to hear more about virus and known specific cancer connections, oncogenes, proto-oncogenes, etc. Thanks for the great show and the hard work that goes into each program.
Okay, I don't have tenure.
So you can make all the liberal comments, right?
Yeah, and I mean, it's also we should probably. I mean, he raises a good point. We should probably try to keep politics out of it. But I should point out, for William's benefit, that this is not entirely liberal paranoia. From where I sit as a journalism, there was a deep and mutual antagonism between the Bush administration and the entire scientific community. So it's very hard to find anybody who's a professional scientist or who's deeply involved in science who doesn't have some hard feelings about that.
Yeah, but I think he's right. We'll keep it out of the.
Yes, absolutely. It's a podcast about viruses.
Yeah, and I don't want to contaminate it. No. We'll just contaminate it with viruses. That's all. That's right. All right. Thanks, William, for writing.
Yep.
Sophie wrote, "Hey, Vincent and co-hosts. I really enjoy your show, and I've learned so much about viruses. I'm only a third semester bachelor in biotechnology, but I'm already hooked on immunology primarily because of you guys."
Cool.
Right. We like that when people get hooked on this stuff. I've recently learned about viral hemorrhagic septicemia virus, which infects trout, Dick's favorite animal, and other fish, and I got really interested since it has quite an effect on our eating habits. If we could eat more sustainable fish, if we could vaccinate them. I wondered if you could talk a bit about it. Dick, you know anything about this VHS? It's a VHS virus.
It's going out of style.
Very hefty salmonids. That's usually what that stands for. I actually don't.
All right, here's the story. Very serious disease of both fresh and saltwater fish. And the fish get hemorrhaging, anemia, bulging eyes, bloated abdomens, and it's lethal. And they get these outbreaks where thousands of fish die. It's a rhabdovirus. Rabies virus, okay? This is very typical that you get very similar viruses across very different species. These are envelope viruses. They have a negative strand RNA genome within them. So this is identified in the middle of the 20th century. And first, I think, in rainbow trout was first found. In
cultured
rainbow trout.
So hatchery fish.
Hatchery fish.
Yeah,
so
hatchery
it got there from, it was a contamination or from a fish. In a hatchery fish, they introduce eggs from the wild.
To begin with, but after a while it's self-perpetuating.
It's all self-perpetuating.
Yeah, it's sustainable.
So it's been found in many other fresh and saltwater fish. First infected freshwater fish in the Western Hemisphere in 2005 in Lake Ontario. So this is a big problem in the Lake District, the Great Lakes, because it's headed for Lake Michigan. And there's a big sport fishing industry in the Great Lakes, of course, and this is going to screw it up.
Yep.
It spreads in the water, and bilges of ships play a big role in transporting it, right? So ships take on water, right? And then they move many, many miles, and then they dump the water out.
That's right.
And that's how the virus goes up the Great Lakes from the ocean.
That's right.
So this is very similar to the salmon virus that we talked about. Infectious salmon anemia virus, against which they have a vaccine, and they're injecting this into fish, which is very tedious. So I suppose in trout farms they could do the same thing, but I'm not aware of a vaccine.
No.
Is this a sustainable food, Dick? What'd you call it?
Hatchery
She says here, if we could eat more sustainable fish. If we could eat more if we could vaccinate them.
I think
that's right?
That's sort of a separate issue.
Yeah.
I mean, fish farming, the sustainability of fish farming varies dramatically from species to species. You look at something like catfish farming; it's very sustainable.
Or tilapia.
Or tilapia, or some of the others. But then, if you look at something like salmon farming or shrimp farming, which is an ecological disaster in many parts of Asia,
and in South and Central America too.
Just because it's farm raised does not necessarily mean it's sustainable.
Okay.
That's right.
All right, thanks, Sophie. Russell wrote, just what we need, another drug-resistant strain with a little help from the victims. So he sent us a Wired article about drug-resistant flu. It's basically an article about Tamiflu in Japanese river water, which we discussed on TWiV 40. Yeah. So we'll provide that link for you if you want to see it, but TWiV 40 is where we talked about it. Thanks, Russell. Andre writes, "Hi, Vincent, Dick, and Alan. I attached an audio file of my question So we have an audio comment. Let's see. Let's turn up the volume for Alan.
Okay.
Which knob is it, Dick?
It's the third from the left.
All right, here we. This has got a lot of background noise.
Hi, Vincent, Dick, and Alan. I did my PhD on respiratory syncytial virus and its fusion protein back in my hometown in Hanover, in Germany. But now I switched topics totally, and I moved to Australia together with my family to do a postdoc on cell migration in a cancer lab here in Sydney. So, although I turned my back on biology, I'm still very fascinated by viruses, and I love to listen to your show. Anyway, I came across this 2008 JGB paper from Ogata and Shibata, where the authors tested subtoxic levels of chlorine dioxide gas as a biocidal agent. As a result, they showed that this substance is able to inhibit infection of influenza A virus in mice. According to Wikipedia, the compound is already in use for general air disinfection, and, for example, was the principal agent used to decontaminate buildings in the US after the 2001 anthrax attacks. Since the substance seems to denature in part the viral membrane proteins, it might be able to destroy those of other viruses as well. So what do you think about this? Would this be a good means to decontaminate sites of recent or potential presence of influenza or other public health viruses? And these sites could be, for instance, hospitals with recent cases, or airports, or other public places. So what is your take on this? Keep up the good work. Cheers, Andre.
Okay, Andre, thank you. So this is a paper from the Journal of General Virology, Protective Effect of Low Concentration Chlorine Dioxide Gas Against Influenza. So low concentrations, they spray it in rooms and it will get rid of the virus. So is this a viable disinfection procedure, do we think?
Sounds like a fumigation.
It's a fumigation, yeah.
The chlorine bothers me. I'm just troubled by the use of chlorine because of the negative effects it has on the stratospheric ozone levels. If it becomes a widely used product, it could have very serious ramifications for the environment in general. So I think even some of the treatment plants are starting to steer away from chlorine, and Clorox, the company, just announced that they're going to drop the use of chlorine in their products from now on, which is unbelievable because they're not changing their name, but they're just going to stop using chlorine because it's such a potent poison.
Wait, so what's going to be in bleach?
Correct. What is going to be in bleach? An oxidant, that's for sure.
Bromines instead of chlorine?
No, I don't know. I don't think they're going to substitute another halide for it, but they're going to work out another way of getting superoxide produced because that's the way chlorine works.
Right.
So they say here this is 0.1 part per million, which is
pretty low.
Below the long-term permissible exposure level in humans.
Yeah.
My feeling is, okay, it's virucidal.
It is.
But if you have a room that's contaminated, you spray the gas, then as soon as people come in, they recontaminate it.
Well, that's true.
So I'm not sure how useful it is, except if you know that whoever's going to be in the room is not contaminated or infected to begin with. So what's your thought on that, Alan?
It's kind of dicey. It's difficult to implement something like this. And to keep it safe.
Sure.
Because in addition to the ozone problem that Dick just pointed out, there's a health problem. Let's not forget this. This is the basis of one of the first chemical weapons.
Phosgene. That's right. Exactly. I was thinking about that too.
So yes, 0.1 part per million is fine as far as we know. And I don't know how much long-term data we have on chlorine dioxide exposure in humans. But apart from that, who's going to sit there watching the meter and making sure that it doesn't go up?
Yeah.
Can you sustainably produce just that very, very low level of chlorine dioxide?
Sure.
So what's your substitute chemical for this to disinfect with? Lysol?
Mine would be a vaccine.
Yeah.
No, but if you had to sterilize the inside of a room, for instance.
Well, if I had to sterilize the inside of a room, I'd use chlorine.
That's be fine.
That's fine for that.
Then you let it dissipate before people come in, right?
Yeah.
But the thing is, as soon as people come in, all right. But if you had a room that you wanted to keep clean, you use chlorine gas. Okay. That's fine.
Right.
But I don't think this is... I saw on the front page of the Times, either last weekend or before, was a photograph of a room. I think it was a school room, and someone was had opened some container on the table. They were all gowned up, and this thing was spewing smoke, and they were disinfecting it. So maybe it was a similar
Sulfur
thing.
dioxide is usually used for that.
Is that right?
Yeah,
Okay.
they do that a lot.
So I think that's kind of silly because here they disinfect the classroom, and then all the
Right.
kids come in who are infected, and they're
Yeah.
you're never going to stop transmission that
That's
way.
true. That's true.
I mean,
And
UV light will also.
a UV light is great. You just have to remember turn it off when the kids come in.
Yes.
I mean, how many times did you start working in the hood and you still had the UV light on?
Exactly.
Yeah. Yeah.
Not that much, but it happens, right?
Right.
So that's what we think, Andre. Thanks for sending us that message. That's great. Shay Lynn writes, "Hey guys, I've been listening to your podcast since its beginning. It is epic."
Whoa.
All right. I'm a microbiology anthropology major at Weber State University in Ogden, Utah. I actually have 2 questions. Dick, I'm the editor of Weber State University's newspaper, and I'm doing a big feature page on vertical farming. Would it be
Cool.
possible for you to email me a quote?
Sure.
A quote to build one? No. I'm just kidding. I think vertical farming is a fantastic idea, and Utah could really use something like this to help keep up with our population growth.
Wow.
Can you send her a quote, Dick?
I'd be happy to.
I didn't realize Utah was short of space, but okay.
They're not.
Well, it's a perception issue.
They are in many
No,
areas.
but-
They are short of water, though.
Alan, that wouldn't be the reason why they would try it out there. I think what they were trying to do is cut down on fossil fuel use. So,
and water.
And water. That's right.
Mm.
So,
Secondly, I was wondering if you guys could do a show on intracellular obligate bacteria like chlamydia, pneumonia, or rickettsia. I think it would be really interesting.
Sure.
Although they are not viruses, they are pretty close function-wise. Thanks so much.
True.
Keep up the great work. Absolutely. So you should listen to TWiV, which will be available soon. And I think we'll do that on TWiV. It's an intracellular parasite. We'll get for, how about Legionella? We have an
Another good
expert
one.
right here.
Sure.
But yes, we will do that. Thanks, Shaylin. Scott writes, "Hey, hi all. Thanks for the podcast. My personal involvement with viruses is limited to catching the occasional cold and working for a funeral services company. But so far I've managed to keep up with you, so you're getting the right level as far as I'm concerned. My question relates to the vaccine for H1N1 pandemic flu, swine flu, as you're trying not to call it. My wife and I have recently had a flu-like illness, and she had a course of Tamiflu as she was worse off than I was. Neither of us had any blood tests, but I strongly suspect that we've had the new pandemic strain as cases are back on the increase in the UK. What I would like to know is, does previous exposure to a live virus affect response to subsequent vaccinations? My initial thoughts are that vaccinating someone who has already had this strain of flu is going to provoke a reaction to the vaccine and make them feel ill, or is this just a bit simplistic? All right, let's take that first. Well, if you get a killed or an inactivated vaccine, there's no effect on of prior immunity, basically, right? You just boost your memory.
Boost. That's what
It's
you
a
do.
boost. Now, with flu mist, the infectious vaccine, if you have antibodies to a related strain that's in the flu mist, it'll probably limit the replication of that vaccine. So, in fact, in adults, flu mist is not as, you don't get as good a response as you would expect, probably because the adults have some pre-existing immunity. And that's just the way it goes. Now, in either case, an injected, inactivated, or a flu mist, you're going to have an immune response. So you may have fever and all the systemic symptoms that would be associated with an immune response. Now, the second one, I know that sharks hardly get cancer. How well do they deal with viruses? Google wasn't very helpful with this, but you probably know better places to look. Thanks again, and keep up the good work.
Well, look in sharks, which do get cancer.
That's true, they do.
They do?
Yeah, sure.
Yes.
Okay. How
That
about
myth has been busted.
How about
Yes.
virus infections?
Why should they be any different than any other life form?
They have antibodies. We know that.
Sure.
Yeah.
So they're there
And they
for
live
a
in the
reason.
ocean, which is swimming with them.
Now, I went into PubMed and I couldn't find any papers on virus infections of sharks.
Really.
They're a very difficult model organism to work with.
Yeah, especially the white sharks.
Well, dogfish wouldn't be so bad to work with, I think.
It's an
Actually,
interesting
I think
question.
some research has been done on dogfish.
It's an interesting question. And so I'm sorry, Scott, we can't tell you. I haven't found anything, which doesn't mean it doesn't exist. But if any listeners know anything, let us know. Send us an email.
Yeah.
Exactly.
Don writes, "Hi, Vincent, Dick, and Alan. Great podcast. I'm a huge fan. Another podcast that I listen to on a semi-regular basis is No Agenda. Guys, remember No Agenda?
We do.
I understand that my tastes stretch eclecticism to its limits, but I believe that it gives me a perspective that may be a little unique, the view from the middle. First, let me say that there is no direct comparison between TWiV and No Agenda. Nevertheless, I get value from both sources. From TWiV, I get a glimpse into a world that I have for many years found fascinating. If I had my life to live over, I would live it as a bioscientist.
Right.
TWiV lets me do that vicariously. From No Agenda, I get entertainment. For example, the first No Agenda show that you commented on informed me about the tons of gold that Iran had shipped to Turkey and how Obama and Hillary Clinton visited Turkey shortly thereafter to get their cut. Where else are you likely to get that kind of information?
Or misinformation.
He's got a little smiley here. So he's joking. While I am not much into conspiracies, I do realize that there are real conspiracies and that often things are not as they seem. I am profoundly skeptical about many things, Big Pharma, for example. Adam Curry's paranoia keeps my skepticism honed. While Curry does not know much about virology, his belief that there are those who would sell us poison for profit is well-founded. It is a good counterpoint to the naive trust of some scientists and academics. Medicine in general has a checkered past and may well include some recent past and present. It is wise to be distrustful. A handful of aspirin for the flu, anyone? Yeah. Remember that story?
I
yeah.
do, of course.
Curry and Dvorak are not without credentials in their fields. Curry, for example, was a pioneer in podcasting. One might even say the co-inventor of the genre. Dvorak is a tech writer that I haven't followed for years. The computer geek in me respects their knowledge even as I am entertained and informed by their jaundiced view of the world. Finally, if you brawl with No Agenda on their turf, you will not fare very well.
This is all true.
They like to play a soundbite from Coach Mike Singletary and claim it for themselves. Our formula is this. We go out, we hit people in the mouth. I don't know what the rest of that quote is.
I think that's the end.
And all that said, TWiV is one of the very few podcasts that I would truly hate to be without. All right. Thank you. I also appreciate Dick's parasite stories and look forward to TWiP. Thanks for your efforts, Don, who says vicariously, Dr. Don, microbiologist, who is otherwise a land surveyor. One more, yes, no? Do you have to leave?
I do. I have someone waiting for me in my office now.
Well, you tell him to...
Wait.
This is more important. One more email I want to do, because this is one more related to No Agenda. Then we'll pick, and then you can leave.
Okay.
BAS writes, thanks for considering my message about making a layperson's podcast about why anti-vax is nonsense. I agree that the information exists in print form or online already, and that it would be too elementary for your primary audience, but that doesn't mean it's completely preaching to the choir. You miss a couple of potential opportunities. Your listeners may not be as skilled as you are in knowing how to refute the bogus claims. Listening to skeptical podcasts is a good way to level up one's own ability to argue successfully with people who are on the fence with reasonable-sounding claims. We otherwise might remain quiet because we lack the facts needed to smack the woo down. A compact, concentrated cast addressing all the misconceptions in one place can be a powerful thing to send to other people who are not already members of your general audience. Anyway, I absolutely respect your choice to stay out of this particular fray. Thanks for doing science. Okay, in respect for Dick, we will move on to our picks of the week. And Dick, would you like to pick and then leave? Is that an option?
No. I can stay for picks of the week. That's not a big deal.
Okay, what is your pick this week, Dick?
I have an article that I want to draw the attention to for our listeners, and it's a feature article in a magazine that comes out called Science News that I'm sure Alan is thoroughly familiar with.
Yes.
And it's a great magazine because it really tells it like it is. And this is an article written by Rachel Ehrenberg. And the name of the article is Enter the Virosphere. And it's an article that has as a headline, as evidence of the influence of viruses escalates, appreciation of these master manipulators grows. and it's got some great visuals. And
We can hold it up for our video audience.
We can actually put this all together.
Enter the virosphere.
Enter the virosphere. And it's got some good basic information in it. And it also says that some life forms that we treasure, like, for instance, these coccolithic phytoplankton organisms.
This one is a coccolithic phytoplankton?
It is. It's a colony of them.
Wow.
And here's a bloom of them.
Interesting.
They are involved in two processes in the ecology of life. One is the sequestration of carbon in the form of calcium carbonate, because their outer shell is made out of calcium carbonate. And then they sink to the bottom of the ocean. So they remove calcium and carbon at the same time. And the second thing they do is they secrete, as part of their metabolism and a byproduct, dimethyl sulfide. And dimethyl sulfide turns out to be a volatile which, when going into the atmosphere, splits apart by a photochemical reaction, releasing sulfur and methane. The sulfur eventually forms sulfate, which is a particle, which then clings to dust particles. And because the dust particle is also covered with a thin layer of water vapor, it dissolves the sulfate and creates sulfuric acid. Now, sulfuric acid, it sounds horrible, but I will just tell you that without sulfuric acid, you cannot make a cloud. Now, Vince smiled at that because
be okay with me.
He probably no. We want clouds, Vince, because otherwise we don't have a mechanism for taking the water of the ocean and moving it over land.
I could get you some buckets, Dick.
You could do that, but it would be salt water.
Okay.
Vince, we need to have fresh water.
All right.
So this coccolithic phytoplankton organism actually does that. It actually enables clouds to form by forming these condensation nuclei. They're called CCNs. And it uses dimethyl sulfide as the mechanism. And because sulfuric acid is hygroscopic,
right,
it tends to absorb more water onto the surface of the particle of dust, and thereby permitting the easy formation of clouds, which then, once they get over land and cool down a little bit, release that water onto the land and form the hydrological cycle.
Great.
So if viruses are interrupting this process...
Yeah. Well, it says here that viruses are major drivers of nutrient and energy cycles.
They are.
So I think they're not disrupting it, probably.
Well, what they're doing is they're controlling populations.
It's like a parasite, isn't it?
It's a controller. It is a parasite. Of course it's a parasite. Vince is baiting me again. At any rate, the article...
It looks great, yeah.
...covers a wide range of topics. She does a wonderful job of pointing out all of the nuances of the way viruses affect life. And there's this little chart on the back that you might want to show also.
This is the... virus is not much more than a genetic material wrapped in a protein coat, yes.
You know, you just said that this morning to the medical students, Vince.
Yeah, they were sleeping, though.
No, they weren't. I was looking at
They have quotes from various virologists here, including Eugene Koonin, who has agreed to come on TWiV. I just have to arrange it. But he's talking about the discovery of mimiviruses, these huge viruses. He said, I think the discovery really messed up the heads of a lot of people. That's great. I like that quote. Very good. All right.
That's my pick.
Enter the virosphere. Thank you, Dr. Despommier.
You're welcome, Dr. Racaniello.
Alan Dove.
Dr. Alan Dove.
Dr. Alan Dove, what have you got?
I picked something that I actually referred to for an article I was working on, the H1N1 timeline interactive map from the World Health Organization.
Cool.
Not to fan the H1N1 flames, but
God.
if you want to,
it's a complicated map.
Track the progress of this thing. It's kind of interesting. You go to this site and you can rewind it day by day.
Previous. I see. Look at that.
So you just keep hitting the previous key, and you see it goes all the way back to April 26, 2009, when the WHO first started following this.
Neat. That's cool. I like that.
You can follow through to subsequent confirmed cases around the world.
And that brings us to 27th May, which is when they stopped really counting, right?
Yeah, that's when they just kind of said, well...
Too many.
No, it's not going to... You can't put it on a map after that.
Yeah.
Not this way, you can't.
Other ways.
Yes.
Tons of other ways.
Sure.
Yes, tons of other ways, but not on a world map with little pins
Very
stuck
nice.
in.
Correct.
Great, thank you. And I have actually two picks, because one I wanted to tell everyone about, because... it was just announced today, cheap Google storage $5 a year for 20 gigs. And you can use that for your email or for your Picasa account, whatever. So they're now selling storage for pretty cheap. 20 gigs, $5 a year. They also will sell 80 and 200 and 400 or a terabyte. So if you need storage for your email and photos, that's it. So that's one. Cheap Google accounts. And the other is just online today, how the CDC estimates the number of flu cases. So this is a page where they tell you how they count flu, because it's inherently difficult because it's not really efficiently reported.
Sure.
It's influenza-like illness, as Josh said.
Yeah.
And they come up with some numbers. This is quite interesting. So the total cases in the U.S. between 0 and 17 years of age are there 8 million, mid-level range. It could range from 5 to 13 million. 18 to 64 years of age, 12 million.
More.
And then 65 years and older, only 2 million. So they're really getting less infected. Very interesting, because they've had this influenza experience, perhaps, or infected with a related virus.
We're just tough old birds.
A tough old bird, which is where flu comes from.
Oh, I see deaths have been rounded to the nearest 10.
Yes.
That's grim.
These are estimates, of course. So anyway, it tells you how they figure it out. So that's quite interesting.
Yep.
And that will do it with for our picks of the week. And let's wrap this baby up. If you're a new listener to TWiV, Dick, you should go over to twiv.tv and check out all our show notes. You can play the podcast there. You can download it, or you can go over to iTunes and subscribe. It's totally free, and you always get the latest episode. TWiV, in case you didn't know, is part of microbeworld.org, which is a community created by ASM, the American Society for Microbiology, to help disseminate information about microbes.
So it's a microbial community.
It's microbial.
Not necessarily the kind that make you sick, however.
No, it's microbial communities of all sorts. Very good.
That's right.
Alan. We're also part of sciencepodcasters.org and promednetwork.com. Send us your questions and comments. We love them. TWiV at twiv.tv. Or you can send us an MP3 file, or call us up on Skype and leave us a message. And you can tag some things on delicious.com for TWiV podcast as well, and that sends it to us. Guys, thank you again. Dr. Despommier at Racaniello.org.
Yes.
Thanks for joining us.
Welcome.
I'm afraid we'll miss you next week, right? You're going to be in India again?
No.
Where?
Next week?
Yeah, you said you weren't going to be here.
I did.
Maybe you will.
I think I will be
All
here,
right, good.
actually. I'll try my best.
See you next week. Dick, thank you and Alan, thank you.
It was fun to be the invisible voice.
We'll figure out how to get you here. And Alan, of course, is at dovedocs.com. We've experimented today with a live video stream. Let us know what you think. It's all been recorded, and I'll put it up somewhere so you can see it. This is where science is headed, video.
I believe.
What's already there, actually.
Yeah.
We're just pulling up in the rear. You've been listening to This Week in Virology, the podcast all about viruses, and in fact, the only one all about viruses and nothing else. Thanks for joining us, everyone. We'll be back next week. Another TWiV is viral.